Hello everyone. Good evening, and welcome to week 1 of our 11-week DSA workshop, which is a part of our Skill It Up campaign. So, a very warm welcome to day 1 of our first week, and our expert mentor will be joining us very soon. So, now is the time to call up your friends and remind them to join this workshop. All right. Till our mentor joins us, what you can do is we have attached a query form below in the link description. So I would urge you all to fill up the form with any and all queries that you might have for us, for which Mr. Shashi will answer at the end of the workshop. All right. Also, I would like to give you one another piece of information is that we have also attached a feedback form in the description below. So if you have any feedback at all regarding the course, uh, regarding the information uh, covered in the course, or any other comments regarding our mentor, do give us your feedback and we will really appreciate it. Okay. All right. Mr. Shashi has arrived, so I'll be adding him now.
Yeah, hi everyone. Am I audible?
Good evening. Yes, sir, you're audible.
Okay, thank you.
All right. So I would take your leave and you please continue. Thank you.
Okay, sure. Thank you. So hi everyone. Sorry for being late. Okay, let me start with the session, right? Uh, Let me share my screen so that I can start with the session. Well, I hope you can see my screen. Great. Okay. Yeah. So today, I mean, this is the first session of, I mean, it's week 1, day 1, right? So today we'll start with the time and space complexity. Then we'll talk about basic mathematics that will help you to solve some coding questions. Right. Apart from that, we'll solve some questions on arrays and string. Apart from questions on basic mathematics, right? So, yeah. Let me. Okay. Let me talk about myself a little bit more. So, I'm Shashi, and uh, I'm currently working as a tech lead and mentor at GeeksforGeeks. So I take multiple courses here. I teach DSL, Go, design patterns, then Java backend. Yeah. So before joining GeeksforGeeks, I was part of Adobe as SD2, and I was there for 2 years. And before Adobe, I was part of Paytm as a software engineer for 1 year. So that's about me. I mean, the idea was, I mean, I have given many interviews off campus and on campus, and I have also, you know, taken some interviews when I was part of Adobe, and here also at GeeksforGeeks, I have taken some interviews. So we'll also talk about like how you can, I mean, represent all these things, how you can solve the problems in the coding interviews. That's why, I mean, that's why I'll be talking about my own experiences, my experience, I mean, my experience of my friends and my seniors, my juniors, uh, so that these things might help you, right? Okay, so today, okay, so today, the first thing that I'll talk about is uh, DSA, right? Like, I mean, how DSA for interviews is different from DSA for CP. CP means competitive programming. Or what is the common thing between competitive programming and interviews, the coding interviews, right? And then we'll talk about time and space complexity. Uh, and after that, I'll complete that coding problem, which I had started in my last session. and the problem was trapping rainwater. So I'll complete that problem today, and then I'll discuss some questions on basic mathematics, like prime numbers and some basic number theories, and then we'll have some problems on arrays and strings. So that's the idea of today's session. And okay, and yeah, I mean, you can ask your questions anytime, right? So this session will be interactive, so you can ask your doubts in the chat. I'll be, I mean, reading your chats, and yeah, I can explain in Hindi as well. So yeah, so we'll use both the languages. Like I can explain something in Hindi as well. Okay. Okay, so let me talk about like what is the syllabus of DSA for the interviews of these top tech companies like Amazon, Microsoft, and Google and Adobe, and what is the syllabus for DSA for competitive programming for CP, right? So for interviews, all these topics like you can start from arrays, strings, then linked lists, stack queue, hashing, uh, trees, heap, then graph, then try, segment tree. Again, some companies can ask questions on segment tree, but you can ignore segment trees at least in the beginning for your interviews. Also, you can ignore topics like some complex topics in graph. Again, in graph, there are a lot of things, right? There are things like max flows. So you can ignore those topics for the interviews. So these are the topic of DS. If we talk about algorithm, we have sorting and searching algorithms. We have DP, greedy, backtracking. We have divide, conquer, right? So all these algorithms are part of your coding interviews for the and for these tech companies, right? Uh, it also includes the string matching algorithms like KMP and other string matching algorithms. Okay, so if I talk about number theory, right? If I talk about like how much number theory or how much mathematics you should know for DSA interviews, in that case, if you know the very basic mathematics, like if you can, I mean, test whether a number is prime or not, if you know the sieve algorithm of finding the prime numbers, if you know like how to use a modulo operator to do something, and what is modulo inverse, and what is I would say very basic, like again finding GCD, or finding, I mean, using Chinese remainder theorem to find something, right? So if you know all these things, that is sufficient for the DSA interviews, right? So I'll share all these links, and in fact all these topics are there at the theory section of your course page, right? So if you have the access of your course page, you can, I'll show you that thing as well, like how you can access your that content we have for this course, right? So so all these things are there on our course page, right? If you talk about competitive programming, for competitive programming you need to know a little bit more of number theory, right? Okay, so again, I mean, competitive programming is not compulsory to crack an interviews, right? uh, but the good thing is that the syllabus for competitive programming or the syllabus for DSA interviews are very same. I would say 70 to 80% things are same in DSA for interviews, or in the CP syllabus, right? There are some topics which are part of DSA, which is very common to the interviews, but these things are not part of competitive programming. Like in competitive programming, you will not have questions on linked list, right? But uh, in the interviews, in the coding interviews, you will have a lot of questions. Like you can be asked a lot of questions on linked list. So there are some topics which are only for interviews. Similarly, for CP, there are a few topics which are only for CP. I mean, interviewers don't ask questions on those topics in the interviews, right? So if you're doing CP, then you can study about all those algorithms or about all those topics, like topics like number theory or so a lot of there are a lot of algorithms in number theory. uh, there's one thing called game theory. Then there are other advanced DSA like binary index tree. Then there's one thing called you know persistent data structures, right? So there are many other topics like heavy light decomposition. So these topics are part of CP. I mean, to be a good computer programmer, you might have to study these topics as well. But for interviews, you can ignore these things, right? So similarly for number theory, for basic mathematics, there are a lot of things for CP, but I will not cover those things because I mean this course, when the intention of this course is to help you in cracking the interviews of these top companies, right? So I won't cover everything of mathematics which is there for CP, but yes, for interviews these things should be sufficient. And also, I mean, we don't have that much time to discuss every problem, so I'll discuss the important concepts and the problems which are very common to the interviews. And again, we have the practice problems at the course page. We have the assignments, or we have, I would say, the theory. I mean, class notes at the course page that you can access, right, for further details, right? So that's the idea. Okay. Uh, and if you have some more doubts regarding CPR interviews, you can ask. I'll be happy to, uh, you know, answer your questions, right? Yeah. So let's start with the time and space complexity, right? What is time and space complexity, and how we can find the time or space complexity for a problem, right? So let me start with the very uh, basic problem, I would say. So let's say the problem is we have to find the sum of first n natural numbers, right? Okay, I'm really sorry for the interruption. Let me start again. Okay. I hope I'm audible now. You can let me know if I'm audible and things are fine now. Uh, okay, looks like things are fine now. Thank you. Really sorry for the interruption. Actually, I was facing some technical issue. Now things are fixed and okay, great. Okay, let me share the screen and then we can start things. Yeah. So I was talking about a problem to find the sum of first n natural numbers, right? Or the sum of first n numbers. Okay. Like if n is 5, then the output will be 15, right? Because the sum of first n numbers are 1, 2, 3, 4, 5, right? So let's say if you have to solve this problem, then what do you think? How we can solve this problem? And sorry for my bad handwriting. I can write better. You know. Okay. So if you talk about approach one or method one, right? So it can be something like this. Let's say we can have a function which will return, which will take an integer n, and this function will return the sum of first n numbers, right? So we can write something like this. Let's say int sum equal to 0, and then we can write we can simply iterate in a loop, like for I equal to 1 to I less than equal to n I plus plus, and we can update the sum as sum plus I. Okay. So I'll be writing code on ID so that you can see the code easily. But let me explain this thing here only. Okay, and then here I can return that variable sum. So this is the one way of solving this problem, right? So this is the method one. So can you talk about like what is the time complexity of this problem? Anyone? Like what is the time complexity of this function? So time complexity means so it simply represents the time required to uh, solve a problem, or the time required to execute that code, right? So that we can compare two methods or two algorithms. So this is like, I mean, the idea of time complexities is to compare uh, among multiple methods that we can have for a given problem. Yeah, it's linear, it's O of n, right? So this is O of n. O of n means, so this is big O of n, and we are talking about worst time complexity, right? So like on course page, if I can share you that thing. So on I mean, on our course page, we have some theory about like what is a worst case analysis, what is the best case analysis, and what is the average case time complexity, right? So we have content about all these things at the course page, but let's only talk about the uh, the worst case analysis. Worst case means uh, this is the upper limit for a given method, right? So it's O of n because the cost of this loop is n. So I mean this loop is running n times. That's why it's O of n. Okay. If I talk about the this is the time complexity which is O of n. If I talk about the space complexity, then what is the space complexity for this problem? Anyone? ठीक है यार, हिंदी में बात कर लेते हैं. हिंदी में ओके. सो स्पेस कॉम्प्लेक्सिटी क्या होगा इसका? Actually, few of our audience is I mean they can't understand Hindi. That's why I'm preferring English, right? Okay, so what about space complexity? So, I mean, here we are not using any extra array or anything which can take some, some good amount of memory. So, we are using a variable called sum. We are using another variable called I, and apart from that, we are not using anything, right? So, I mean, the cost of the space complexity for this variable is O of 1, and because we are declaring only one variable. So let's say if you are creating an array of size n, so this will take O of n space complexity, right? Because we are allocating a space for n elements, n integers, right? That's why when we are creating an array of size n, the space complexity will be O of n. Okay, right? But here we are not doing that thing. That means the space complexity for this method is O of 1 only. Okay. Uh, so let's try to optimize this problem. I mean, can we write a better code than this? Can we do something which can have a better time complexity? Okay. So so again, to find the sum of first n numbers, what we can do is we can, let's say this is function 2. So this is a basically method 2, right? Integer n. I'll try to write a pseudocode only so that everyone can understand that code. So yeah, so what we can do is we can simply return n cross n plus 1 by 2, right? So if you know that this formula, uh, so this formula will help us to find the sum of first n numbers, right? Okay, now what do you think? So this is a method 2 to find the sum of first n numbers. Okay, so what do you think? What is the time complexity of this problem now? Yeah, I'll talk about that thing, like why time complexity is that important, right? So I'll talk about all these things, don't worry. So let me, complete this example. Then I'll talk like why time and space complexity is important for any uh, problem, I would say. Yeah, it's O of 1, right? Because we are not iterating something. We are not doing something n times. Here we are writing a loop, and that loop is running n times. That's why the time complexity was O of n, right? But here it's a single line, right? So we are simply doing some calculation. So it's O of 1. Now the time complexity is O of 1. And what about a space? What about a space complexity? Yeah, a space is also O of 1 because we are not using any extra space, right? So a space is also O of 1. Okay. So similarly, I mean, the same problem can be solved in multiple ways, right? Like here we have method 1, here we have method 2. So what do you think? Which method is better? Method 1 or method 2? So don't worry. I mean, we'll be talking about all these things, like how we can calculate the time and the space complexity for each problem. So don't worry about that. I'm simply starting this thing with very basic example. Well, yeah. So method 1 is taking O of n time. It's linear time, right? And it is taking only constant time, O of 1. So obviously method 1 is better. Sorry, method 2 is better, right? So method 2 is better than method 1. So the idea of time complexity is it helps us to, again, I mean, the one way to decide which algorithm or which method is better, what we can do is we can take a machine and we can write uh, the code, let's say using method 1, right? And we can simply find the execution time of method 1, right? So let's say the execution time of method 1 is t1, and let's say the execution time of method 2 on the same machine for same input is T2, right? So if T2 is less than T1, that means okay, T2 is a better approach because it is taking less time than T1, right? So that could be the one way. But again, I mean that's not the efficient way to finding or to comparing the two algorithms, right? Because we are writing code, then we are running them on the same machine. We are noting down the time and everything. So that's one way to compare two approaches or two algorithms. But another efficient way to compare the two methods or two algorithms or two approaches can be uh, using time complexity, right? So if we can denote an algorithm or an approach in, let's say, in big O of n, right? So in big O notation. So if we can say like, okay, we have approach which is, let's say, taking big O of n square. So n square means when we'll have two loops. So I'll talk about that thing later. And let's say we have another approach which is taking time O of n, and we have something which is taking time, let's say O of 1, right? So if we can, I mean, decide the time complexity, or we can find the time complexity of an approach or of an algorithm without writing code, or I would say without running that code on a machine, right? So this is how we can compare that, okay, this third approach is the best one, right? Because it has the least time complexity. Okay. So again, the purpose of time complexity is to compare two or multiple approaches or multiple algorithms of a same problem. So I mean, this is okay. So I'll be talking about time and space complexity throughout the lectures. Like in all these 11 weeks, every day when we'll talk about a problem, we'll talk about multiple solutions. We'll talk about multiple approaches, and we'll compare all these approaches using this time and space complexity, right? So I'm not done with the time and space complexity. We will discuss about this thing in every lecture, in fact in after every question, right? So this is just the beginning of time and space complexity. So if you don't know how to calculate the time complexity of a recursive code of a tree, or of a code of a graph, don't worry, we'll discuss about all those things when we will cover that topic. Let's say when we'll cover trees or graph or dp, then we'll see like, okay, how we can calculate the time or space complexity of a problem based on tree or graph or something else, right? So I won't talk about all these things right now. I mean, the basic idea was just to help you to understand like, okay, why time complexity is important, right? So that we can compare multiple approaches, multiple algorithms, right? So that was the intention of finding the time complexity. If I talk about space complexity, it simply denotes the space, the memory required for that code, right? So if something is in O of 1, that means, okay, we are not allocating very large amount of memory for that program. Let's say when we are creating an array of size n, that means that, so let's say if you are creating an array of size n inside a method, that means, okay, we are allocating n extra space for those n integers, right? So it is O of n space. That means we need, I mean, this code needs an uh, you know a, the space for n elements, right? Similarly, if we have a matrix of size m cross n, so let's say if we are creating a matrix of size m cross n, so what do you think? What should be the space complexity for? So let's say we have a function, and inside that function we are creating a matrix of size m cross n. So what do you think? What should be the space complexity for? I mean, that function. Yeah, it's m cross n, right? Yeah, it's m cross n. Great. Because the number of elements in that matrix is m cross n. That's why the space complexity is O of n, m cross n. Okay. Okay, makes sense. Yeah. So I mean, this is just the beginning of time and space complexity. I'll repeat that. Okay, we will be talking about all these things. I mean, space and time complexity in every lecture and after every problem, right? So don't worry about like how we can calculate about the time and space complexity of a problem. We'll talk about all these things when we will discuss that topic. Like when I'll discuss linked list, I'll talk about like how we can find the time complexity of a problem or of a solution based on linked list, right? So we'll discuss all these things in every lecture. So it's not the end of time and space complexity analysis. So I hope you understood at least this problem, like what is the meaning of time and space complexity and how we can, again, I mean, how. So let's say if we have again two methods, and in method one we are using O of 1 space, and in method 2 we are using O of n space, and let's say the time complexity of both the approaches are same. In that case we should go with the method 1 because it has it has the least space complexity, right? So that's why, I mean, we should try to solve a problem with least space required, right? So that's the idea of space complexity. Okay. Yeah. So again, I'll talk about all these things, like how we can calculate these things with few more examples, right? So let me do one thing. Uh, I mean, if you have attended my previous session, then you can remember that we are talking about a problem which was trapping rainwater problem. Okay. So uh, I mean, discuss that problem again. That what is trapping rainwater problem and how we can solve that problem using multiple approaches. And with the help of that problem as well, I'll talk about, like, you know uh, we'll compare multiple approaches of that problem using time and space complexities, right? So let me quickly show you that problem so that you can easily use that, right? So it's, if you don't remember the problem was we will be given an array uh, like this, which will have some elements. So here 202 means uh, when 2 means we have a wall of height 2 like this. 0 means we have a wall of height 0, and 2 means we have a wall of height 2 again, right? So we have to find the total water trapped in between the walls. Okay. So it's a very common interview question, and it has been asked in companies like Facebook, Amazon, Microsoft, Adobe. So it's a very common interview question, and we can solve this question with simple for loop and if else condition, right? So let's see how we can solve that. Uh, Actually, I had talked about this problem in my previous lecture, but let me explain it again so that you can understand if you have not attended my first, I mean, or zeroth session. So let's say if we have an array like this. So like let's say we have 3, then 0, then 2, then 0, then 4, right? So for this array, 3 means we have a wall of height 3, then we have a wall of height 0, then we have a wall of height 2, then 0, then 4, right? So this is the meaning of this array. So when it rains, we'll have water, like this. So like at this point, we'll have 3 units of water. On the top of this wall, we'll have 1 unit of water, right? And similarly, at this point, we'll have 3 units of water, right? So total water tap will be 3 plus 1 plus 3, which is 7. Okay. right? So the question is, we'll be given an array like this, and we have to find the total water that can be trapped in between the walls. Like for this example, the answer is 7. I hope you understood the problem, right? Okay. Yeah, so anyone who could not understand this problem, so that I can explain again if it's not clear. Okay. So great. Another example could be, let's say if we have an array like this, 3, 4, and 2. In this case, the answer will be 0 because we'll have a 3, 4, and 2, right? So in this case, we'll not have any water trapped. That's why the answer will be 0. But for this input, the answer will be 7. So I had discussed about the uh, yeah. So we'll be given an array, and we have to find the total water that can be trapped in between the walls. So that is the problem. So we'll have this array, which represents the height of a wall. Like 3 means we have a wall of height 3 here. 0 means we have a wall of height 0 here. Then 2, then 0, then 4, right? So after rain, we'll have 3 units of water trapped here. We'll have 1 unit of water trapped on the top of this wall, and then we'll have 3 units of water again, right? So that's the question. So we'll be given an array. We have to return the total water that can be trapped. Like for this input, the answer is 7. For this input, the answer is 2 because we can't have any water trapped. Great. So if you remember my approach, which I had talked about in my last lecture, which was the first session, the approach was, for each index, what we can do is we can find the left boundary, right? Left boundary means the maximum value in the left side. So we can simply find the left max value, means it's a left boundary, the maximum value in the left side of that index. Let's say I'm talking about this index, right, where the height of the wall is 2. Let's say I'm talking about this index. So for this index, the left max is 3. Okay, for this index the left boundary is 3, and right max means right boundary, so right boundary is 4. Okay, so we'll take minimum of both. So I'm taking mean of both these values, mean of left max and mean of right max, and then we can subtract the height of wall at that ith index. Like for this example, for this index where the height is 2, I'm talking about this index, right? So for this index, what is the height of the wall? It is 2, right? So it is nothing but mean of 3 and 4 is 3 minus 2, which is 1. That means we will have 1 unit of water trapped on the top of this wall. Okay. Similarly, if I talk about this index where the height of the wall is 0, so I'm talking about this index now. So for this index, again, what is the left boundary? Okay, I have talked about like why we are taking minimums. I'll talk about again like why we are taking min of both these things, right? So min is, so if I talk about this point, what is the left boundary? 3. Awesome. Sorry, it's 3. And what about right boundary or right max? It is 4. So mean of 3 and 4 is 3. and minus the height of wall at that index is 0, so which is 3. So that's why we have 3 units of water trapped at this index. Okay, looks like some of you are not able to understand this. So, okay, okay. Let me know if the question is not clear, so that I can explain things again. Mhm. Or what I can do is see the left max means maximum value in the left side, right? So for this point, the maximum value in the left side is 3, not 2. That's why we are taking 3. So left boundary means maximum value in the left side. Okay, looks like some of you are able to understand that's good. See, the logic is we are simply finding the left and right boundary, right? Like let's say if we have something like this. Let's say we have 3 walls of height 2, 0. Let's say we have 3 walls of height 2, 1 and 6, right? So we have a wall of height 2, then 0, and then a wall of height 6. Okay. So what do you think? Again, we have a wall of height 1 as well here. So it's 2, 1 and 6. So what do you think? What should be the answer for this example? So where after rain, I mean, the water trap will be here, right? The answer will be 1 unit, which is on the top of this wall. Okay. So how we can find, the amount of water trapped at this index? How we can find that? So it's quite simple. We have to look for the left max, or I would say left boundary, which is 2 here, and right boundary is 6. So we have to take mean, right? Then only we can calculate the actual water trapped at at that index, right? So that's why we are taking mean of 2 and 6 minus 1. 1 is the height of wall at that index. That's why we'll have 2 minus 1, which is 1. That's why 1 unit is the answer. So that's why we're taking the minimum, right? Because if we have 2 walls, like in the left side we have a wall of height 2, in the right side we have a wall of height 6. So we'll have to take the minimum, right? Then only we can calculate the actual answer. Okay, because the water, if I mean, let's say if you are not considering the mean, in that case, okay, I think this is self-explanatory, right? This is quite easy to understand. Mhm. Okay, yeah, so that's that, and that's why we are taking mean of both these values, right? The mean of left max and right max. Okay, so I hope the approach is clear now. Uh, mhm. Okay, now let's try to again. So one question from Anjali Kumar is so how we can find the left max and right max? That's a good question, right? So what do you think? How we can find the left max and right max? So idea is simple. Let's say if I want to find the left max for this index, then what I can do is I can simply iterate in the left portion of this array. I mean the portion of the array which is in the left of this point, and then I'll find the maximum value till that point. Okay. So I can simply iterate from leftmost point, and I'll iterate to that point, and I can simply find the maximum till that point. Okay. Apart from that, we can also use we can also optimize that, but I'll talk about that thing later, like how we can optimize finding the left max and right max. Yeah, that's correct, Aditi. Anbhoy is saying divide array into two parts. Okay. Purush, I think what if there is bigger? Okay, if there is bigger, we can optimize it further, right? We have ways to optimize it. So don't worry about uh, these things. Sorry. Okay. So for this, yeah, for this example, the output is zero. Sorry. So for this example, the output is zero. Sorry, it's not two. Abhishek is asking how to create logic. There's no rule or there's no shortcut way to create the logic. I mean, the simple idea is when you will solve a lot of problems, your brain will be trained to create logic, right? So this is how you can train your brain. So it's so simple. I mean, you have to practice a lot of questions so that your brain can be trained and your brain can be able to solve similar questions, I would say. So if you have solved a particular type of problem and let's say you are asked a question which is very similar to the that one, so I mean you'll be able to create that logic easily. So that's why there is a need of solving a variety of problems. It's not heap, right? I mean, okay. Okay, let me convert this logic to code so that you can understand, you can have some more clarity, right? So and please help me while writing the code. Okay. Yeah, sure. I'll go slow. Don't worry. Yeah. Okay. Let me think. I mean, let's see like how we can code this logic, right? So let's say we have a function called find total. In the input we'll have array, and we have n. N is the number of elements in the array. So n is the size of the array. Uh, so idea is simple. We'll simply find answer is nothing but the. Let me increase the font size. I hope my code is visible clearly. Mhm. Okay, so see, I mean, we'll learn all these things while discussing questions, right? So don't worry about the speed. Okay, the code will be language independent. So if you code in C or C++ or Java or in Python, all of you will be able to understand the code. So don't worry about the code. Okay. I hope my code is visible. Okay, thanks. So let's say answer is total water. So let's say it's zero initially. So what we can do is we can go to each index and we can find water trapped at that index, and then we can add that water to the. Let me write it like total water. Water will be the better variable name. This is our answer, right? I'm iterating from a starting index. So the idea is I'm going to each index and I'm finding water trapped at that index, right? And then I'll add that water to the total water and then we'll return that, right? And return the total water. So that's the idea. Now the question is how to find how much water will be there at ith index. Well, I hope now the code should be visible. I have increased the font size. So yeah, so now like how to find the water trapped at this index. If I can explain from here, like to find the height at this index, what you can do. Again, you can ignore for the first and last index, you will not have any water. So you can ignore the first and last index. So in loop, what we can change is we can start the loop from index 1, and the last value can be should be less than n minus 1, right? Because we are not, because at the last index we will not have any water, right? The first and last index we are ignoring. If we talk about other indices, like if I talk about this index, right, where the height is 0. So what we have to do is we have to find the left max and then right max, and then we have to take the mean of both these values, and then we have to subtract the height at that index, right? Like for this, the left max is 3, the right max is 4 minus 0, which is 3, and that's why we have 3 units of water at this index. I hope this logic is clear, right? Yeah, Aditi has shared, I mean, total plus mean of left, right minus. Yeah, that's correct. Okay, so some of are saying please go faster, some are saying please go slower. So I don't know how to. I mean, should I increase my speed or should I slow down? I don't know. Like, okay, okay. So let me. I hope you understood the logic, right? So the idea is simple: total water plus we take mean of left max, right? So left max is, let's say, let me write a variable like left max. So left max is nothing but the uh, value in the left side for that index, right? So we have a function called, let's say, find left max. So this function will find the left max for this that index I. So I'm passing array n and I. We have one more variable called right max. So increasing the speed, if you are able to understand it properly. Well, then let's say we have one more function that will help us to find the right max. So now I have left max and right max. So it's quite simple. So we'll take mean of both these values, mean of left max and mean of right max, and then subtract with array of I. And then we are done, right? Uh, let's say we have a function which will calculate the left max and right max for us. So I'll talk about that function later, but I hope now this code makes some sense. Okay. Okay, see, I mean, this course is for beginners as well. That's why I'm going with little slow. Of course, I'll be increasing my speed if from next lecture. So this is the first session. That's why I'm not writing. I'm not going with a good speed. Okay, great. So looks like most of you are able to understand it. So let's see if I have to code this thing. I mean, finding the max. So what we can do is, let's say we have this array I. What we can do is, let's say we can find again max is something called, let's say, 0. The idea is we'll iterate from ith index. Sorry, let's say this is equal to 0. Again, I'm including I. I'll talk about that, like why I'm including that ith index. Max is nothing but the max of this mx or as maximum. Basically, maximum is nothing but the maximum value till that ith index. Left max is nothing but the maximum value till that ith index, right? And then we can return that maximum. Yeah. So this is how we can write the code for finding left max. I think it should be clear. Why use n minus 1? Because at first and last index, we can't have water, right? That's why I'm ignoring the first and last index. Because first and last index will be the boundaries of, this will be the boundaries wall. So we can't have water at the first and last index. That's why I'm ignoring the 0th index and the last index. Is that clear? Yeah, I'll talk about the time and space complexity. Don't worry about that. Yeah, there is an inbuilt function called max. But also you can write your own max function, right? So it's a simple if else. But I'm using inbuilt max and min function. But you can write your own max and min function. Okay, now the question from Chitija Patil is, can you explain why we have included I? Okay, it's a nice question which I was expecting. So I have included ith index as well, right? So left max means the maximum value in the left side, including that point. Let's see how it will help us. And by the way, this is not an easy problem. This is a problem which has been asked in multiple companies like Facebook, Amazon, Google. So it's a very good question. And the good thing is that we don't need any fancy algorithm to solve this. That's why I'm solving this problem as my first problem, right? Because I mean, with the help of this problem, I can explain a lot of things, right? Like how to build a logic, how to convert that logic to code, then how we can optimize the code, then how we can compare multiple approaches of that problem with the help of time and space complexity. So I'll be doing all these things with the help of this problem, right? That's why I have, you know, gone with this problem, right? So let's say we have something like this: 2, 5, and 4, right? So in this case, we have a high wall of height 2, then we have a wall of height 5, then we have a wall of height 4, right? Okay, 2, 5, and 4. So let's say if I'm calculating the water trap rate index, this index, right? So for this index, let's say if I'm not including this index, in that case the left max will be 2, the right max will be 4, and value at this index will be 5. So it will be minus 3, right? So the one way is, if I'm not including the left max, I'm not including that index in the left max. In that case, uh, I mean, in that case, we'll have some negative value, right? So we can either handle that negative value separately, or what we can do is we can include that value, that index, in the left max itself. So what we can do is we can write, like for this point, the left max will be 5 itself. So now left max means maximum value in the left side, including that point. So left max is 5. Similarly, the right max is nothing but 5, because I'm again including that point. So it's 5 minus 5, which means 0, which is true. I mean, we will have 0 water on the top of it. That's why I'm including that ith value, that ith index, while calculating the left max and right max. Is it clear? Like why I'm including this ith value, so that I can, easily, so that I don't need to handle the negative values separately. Okay. Okay, Chandan Singh, see, the idea is we are ignoring, okay, you can go with, okay. So what I'm saying is I'm ignoring the first and last index, right? So I'm ignoring because we can't have water at first and last index. That's why we are ignoring 0th and n minus 1th index. Okay. So any doubt in the concept and anything? So Aniket, which thing I should explain? Okay, looks like you have to study about that. So this means the loop will run. Okay, so this is the, I mean, we're simply ignoring the n cell, right? So this is n minus 1 only. I hope you know how, like, in array, the first means 0th index, and last means n minus 1th index, right? So I hope it will help you. Okay, looks like this thing is clear for most of you. So let me proceed ahead. Okay. Now, what about the time? Again, I hope you can write you can write this function called find right max. So let me help you. Find right max will be similar to finding left max. So we'll have in the name, right? So we'll have something like this, right max. Uh, we'll start from large value n minus 1. We'll come to the value uh, we compare maximum and array of j. Yeah. So in this case, we are iterating from last index, the rightmost index, to the ith index, right? That's why we have this code. Okay. So don't worry, I'll be sharing all this, I mean, class notes with you. I'll be sharing my PPTs and all these codes with you. Also, I'll be sharing the link of this problem, right? Like I'll be sharing this link, right? So that you can understand the problem and you can see the complete code here. Okay. So don't worry about the notes and everything. Okay. Yeah. So again, if you're not able to understand this problem, that's perfectly fine. Uh, I mean, after a few lectures, you will be able to understand this code. So what you can do is like this video will be there on YouTube, so you can watch the recording again if you are not able to understand this, right? And I had talked about this approach in my first session, which is also there on YouTube. So you can watch that video to understand this question completely. So I hope you won't have any issue in understanding these things, right? Like looks like most of you are able to understand this. So yeah, I'll be sharing these notes. So don't worry about the notes. Okay. So this should be area of J. That's thank you. Now let's talk about the time and space complexity for this problem. I have also one thing to talk about. Okay, this is like this course is for beginners and for someone who knows the basic. Like uh, so this in this course I'll be talking about mostly easy and medium questions. I'll not be talking about the hard questions, right? So if you are looking for very deep details, like let's say if you are looking for a course that will help you to understand everything from beginning to end, like from very easy to hard level questions, so for that thing we have a course. So okay, so like you can simply go to our courses page and Yeah, so we have multiple live courses. I hope you have seen some of them. And in those live courses, we have multiple courses. Like we have courses like full stack, we have courses on Java backend, then we have a course on Android, machine learning, system design, competitive programming. We have one course called Geeks classes, right? So this course is for DSA mainly, for interviews mainly. So yeah, I mean, so in this course, again, it's a paid course. It's not a free course, right? So in this free course, in this 11-week workshop, I'll be, I mean, teaching things from basics to, I would say, medium level. I can also talk about some very few hard questions, but again, I don't have that much time to cover everything, right? So if you are looking for a course in which you can find everything, so yeah, you can try this course, like the Geeks classes live. It's a live course on weekends. It's a 18-week course, right? Sorry, so 9-week course. So total, it will have 18 lectures, I would say. And the mentor is like he is a SD1 at Amazon, uh, Sachin, and it has everything like all the topics which is there for your placement, right? Okay. So yeah, so that's about this course. Uh, so I can share the link of this course as well in the chat. You want to see that? Now let me. Yeah, so we can share the link in the video description as well if you want to have a look at that course. Right. Okay, let me. Hmm. So now let's talk about the time and the space complexity for this solution, right? Like how. Anyone? Okay. So this line, right? Like this for loop will take big of n, right? Sorry, I can't run the code right here, right? I mean, I don't have that much time. So what I can do is uh, so any I can't try. I mean, I don't have that much time to compile and try it, show you everything. But what you can do is on Geeks for Geeks, like on this link, uh, sorry. So I'll share the link of this problem where you can find the complete code and you can run on that course page itself, right? I mean, I mean on that link itself. Yeah. So this line will take big of n time. And what about the cost of this function? What is the time complexity of this function? Find left max. It's often, right? And what about the time complexity of this problem? I mean, time complexity of this function. It's also often, right? So basically, we are calling these two functions. Like calling this function will take O of n, but we are calling these two function n times, right? That's why it will be n square, n cross n square. Time is n square because in a for loop we are calling a function. This function is O of n plus O of n. It's 2n, and we are calling these two functions n times. That's why it's n square. I hope this is clear, right? Like how it's n square. Let me know if you are not able to understand something. Like why it's n square. N is the size of the array, right? So n is the total walls we have. Okay. Okay, yeah, it's not the most optimized, but yeah, it's a solution, right? It's approach one, which is working fine. Okay. Okay, awesome. So can we do something to optimize it? Can we do something so that we can, I mean, this thing can be optimized further? So if somehow we can find the lift max of a given index in O of 1 in constant time, right? In that case, we'll be able to solve this problem in O of 1. I mean, in that case, we'll be able to solve this problem in O of n, right? We can find left max and find the right max in O of 1 in constant time somehow. In that case, the cost of this function will reduce to O of n only. Instead of n square, it will become O of n. So how we can find the left max and right max in O of 1? Anyone? Again, so some of you are not able to understand this. So what you can do is, yeah, we can use actually array, right? We can use two arrays to optimize it. We can have a left array and we can have a right array, and uh, using the two arrays we can optimize it, right? So you can do one thing. You can try to think about yourself, like how we can optimize this function from O of n to O of 1 so that the total time complexity can reduce to O of n, right? So it's a homework for you. And if you're not able to solve by yourself, then I'll discuss, the optimized solution in my next lecture so that you can. The idea is I want you to try this thing first, and then I'll discuss that approach in the next lecture. Okay. Let me discuss some problems on, I would say, number theory or simple mathematics, right? And then I'll solve some more questions on arrays and strings if I'll have the time. Okay. Yeah. Again, I mean, the hint is you can use arrays, right? You can use arrays to optimize these two things, right? I can do that, but some of you are not able to understand this thing. That's why I don't want to discuss it right now, because because that will take some more time, and some of you might not be able to understand this. That's why I'm you know I'm not discussing about the best approach right here. So you can try by yourself, and then I can quickly discuss that approach in the next lecture. That won't take more than 10 minutes. Okay. So let's discuss a new problem called, check for prime number, right? Again, you should know how you can check whether a number is prime or not, right? So let's say you have to write a function, real function, and that will check whether the number is prime or not. So you'll be given a number n. You have to tell whether the number is prime or not. Like, let's say if the number is, let's say if n is 5, then the output should be true because it's a prime number. Let's say if n is 24, it should be false because 24 is not a prime number. I hope you got the question. The question is simply checking whether the number is uh, prime or not, right? Okay. Yeah, so Preeti is saying iterate from I equal to 0 to n by 2. Okay, that's correct. So Preeti, can you optimize it further? Like you are starting from 0 to n by 2. That will take O of n time. So can we do something better? Okay, and if some of you are not able to understand the first problem, what you can do is you can simply uh, you know watch the video again because it's there on YouTube. You can also watch the previous video in which I have talked about the approach of this problem, and you can also try this problem searching on like on Geeks for Geeks. You can also find the complete solution. So you can try that solution by yourself first. So that might help you to understand this one. So it was a complex problem, and I wanted to start with little complex one so that you can understand a lot of things. So that you can I would say, I mean, you can learn a lot of things in a same problem, right? That's why I'm discussing this one, right? It's not easy one. It's a good question, right? That's why I'm talking about. So if you're not able to understand it, that's perfectly fine. Uh, gives I mean you can try this question by yourself again, and then I'll talk about the most optimized way in the next lecture. I think after spending let's say 1 hour, you can understand this completely. So it's not that tough. Okay, so what about the is prime number? Yeah, that's quite simple. What we can do is we can simply check from I equal to 0 to sorry, from I equal to, again, every number will be visible by 1, divisible by 1, so we can ignore 1, right? We can start from 2, we can go till n. So if that number is, let's say if that number is 2 by n, uh, then we can return false, right? Otherwise we can return true. This is the simplest way, right? We are simply iterating from 2 equal to n. If that number is divisible by I, that means that number can't be a prime. That's why we are returning false. Yeah. So can we do something better? Yeah, someone said instead of iterating from, so yeah, this function has complexity O of n. Because we have a loop from 1 to n, right? Someone said like we can optimize till n by 2. That's fine. So now what should be the time complexity for the second approach? It will be n by 2, right? Yeah, it will be n by 2. Again, n by 2 is nothing but n only, right? N by 2 is in the range of n only. So it's of n itself, right? So another thing that we can do is we can get till the square root of n. Let's say we have a function called square t which will return the square root of that number. So we are iterating till the square root of n, because again all the divisors of a number will be like there will be divisor less than or equal to square t of that number if that number is not a prime number. Yeah. Now the cost of this function is big O of, yeah, it's big O of root n, right? It's big O of square root n. It's little better than the previous one. It's better than O of n. Yes, Joy, we'll talk about the Sieve algorithm next. Mhm. So any doubt in this simple problem, like how we are finding the checking whether the number is prime or not? Anyone who is not able to understand this? Okay. Well, now let's say the next question is we have to find all the prime numbers from 1 to n. We'll be given a range like n, like let's say n is 10 to the power, let's say one is n is 1000, right? So the idea is we have to print, or let's say n is 100, right? So we'll have to print all the prime numbers in the range of 1 to 100. So the prime numbers will be 2, 3, 5, 7. So how we can find all the prime numbers, or how we can, let's say, print, I would say, let's say print all the prime numbers. We can print all the prime numbers from 1 to n. Again, it's a problem based on mathematics. That's why. So this, checking for prime numbers is a very, I would say, is the most useful topic in basic mathematics for coding, for DSA coding, and also for the interviews. Yeah, so we have something called Sieve of, so it's difficult to pronounce. Let me copy the spelling. Yeah, so it's of Eratosthenes, right? So it's difficult to pronounce it. Right? So you can call it Sieve. That's for simplicity. Sieve of Eratosthenes, right? So it's difficult to pronunciate, right? Yeah. So I will call it Sieve simply so that I can save some time. So we have an algorithm called Sieve, which will help us to find all the prime numbers in a range from 1 to n, right? Okay. Uh, okay. So Ganesh, we're using basic mathematics to solve some problems, right? So the idea is solving some problems using that basic mathematics, right? So here we just use this modular operator to find that thing. I mean, I won't be teaching mathematics like set theory or number theory or something. I'll be talking about the logic which is useful to solve some problems based on some mathematics, based on number theory, and which is important for interviews. Okay, so this thing is important for interviews. So see, I mean, this C algorithm is basic mathematics, right? So this is the basic mathematics. But I would say this is the most useful, uh, I would say, approach or algorithm to solve a number theory questions. Well, uh, hmm. So what we do in this C algorithm, what we do is, okay, I mean, let's say if you have to print all the parameters from 1 to n. So if we can solve it without the C algorithm, so what we can do is we can simply, so let me write this is method 1, which is not optimized. Method 1 could be without using, without using C algorithm, right? So what we can do is we can simply iterate from, let's say, 1 is not a prime number, so you can ignore 1. So 1 to less than n I plus plus. We have already a function called is prime, right? So we can simply call that function to check whether that number is prime or not. So we have a function called is prime. If that ith number is prime, then I'll simply print that ith number, and we are done, right? So this is the method 1 using which we can, uh, we can find the all the prime numbers in the range of 1 to n, right? I hope the method 1 is clear to everyone. So we're simply iterating from 2 to n, and if that number is prime, because we have a function called is prime, which will help us to find whether the number is prime or not. So if the number is prime, then we are simply printing it, right? So what is the cost of this function? So I mean, what is the cost of this method 1? let's say we have a function called fun1. We are given n. What do you think? What is the cost of this function 1? Is let's say this is printing prime numbers. So print. What is the cost of this function? This is the basic version 1 of this problem. Yeah, this is, so this step will take big O of n, because we have a loop here, and we have a function which runs in O of root n, right? So it works in square t of n. Total cost of this function is nothing but O of n cross square root of n. So it's n to the power 1.5. That's correct, right? So this is the one thing. Yeah, it's n to the power 2 by 3, you can say. So can we do something better so that we can find all the numbers in the range of 1 to n? So for that thing, we have one algorithm called Sieve, right? So this algorithm will help us to printing or finding all the numbers less than n. Let's see how it works. Well, so let's say the number is 30, right? So what I'll do is I'll create an array of size 30 and we'll have all these elements in the array. Then we have 11, 12, 13, 14, and so on, right? Then we have 21, 22, 23, and so on. Yeah. So, so let's say we have an array. We have a Boolean array. Boolean means it will be true or false of size 30. And again, I mean, at 0th index of this array will have 1. At 1 index will have 2, and so on, right? So yeah, okay. It's again, it's sorry, it's a Boolean array, so it will be only true and false, right? So the idea is the first index, or I would say 0th index of this array will represent this number. Second will represent this number, right? And let's say we are considering all these numbers as prime initially. So let's say all the numbers are prime number, which means all these values in this Boolean array will be true. Okay. And then what we'll do is we'll start from 2, and again 2 is a prime number, so we can print 2 because it's a prime number. Or let's say we'll print it later. So okay, so again 2 is a prime number, so again the multiples of 2 can't be prime, right? So let's say all of these numbers are prime initially, so 2 is a prime. We are ignoring 1 because 1 is not a prime number, right? So we're starting from 2, and 2 is true means okay, 2 is a prime number, and then we are marking all the multiples of 2 as non-prime because they can't be prime because they are divisible by 2. So multiples of 2 are 4, 6, 8, 10, 12, 14, and so on, right? All these numbers are multiple of 2, so they can't be prime. So basically, for all these values, I will mark them as false because they are not prime numbers. They are non-prime numbers. Okay. Right. Similarly, then the next value, which is prime, is 3 because 3 is again it's true, so it is not it's a prime number. It's not false. So now we are at 3, and now I will mark all the multiples of 3 as non-prime. So it is already marked. So I'll mark 9, then mark 15, then 18, then 21, and so on, right? Okay. Uh, so basically, we are again marking them as false because they can't be prime because they are multiples of 3, and so on. Again, we'll pick 5. So basically, I am picking a number which is true. I mean, for which the thing. I mean, the value in the index is true. The value in the array is true. That means okay, that is a prime number. Like 5 is a prime number, and then I'll mark all the multiples of 5 as false. Okay. Like now 25 will be false because that's not a prime number, so it will be false now. And similarly, like 7, then 14, then 21, 28, and all these numbers will be prime, right? Then we'll mark multiples of 11 as primes, like 22, 23, and so on, right? So that's the idea. We'll have an array, Boolean array, and all these values in the array will be true because we are considering all these uh, values, I mean, all these numbers as prime initially, and then we are starting with a prime number like 2, and we are marking all the multiples of 2 as non-prime, like all the multiples of 2 like 4, 6, 8, and so on are non-prime numbers. Similarly, we'll pick the next prime number which is 3, and I'll again mark all the uh, I would say all the numbers which are divisible by 3, or I would say multiples of 3 will be non-prime. So that's why we are marking them as false. So that's the idea of so, and in the last we'll iterate in this Boolean array, and for those values which has value true, so they will be prime, like for 2, 3, 5, 7. So for all these numbers, the value will be true. That's why they are the prime numbers, and we'll print them. So that's the idea of this Sieve algorithm. Okay. Yes, Monica, we can use this thing from the range as well, like from N1 to N2 as well. Yeah, so that will work in that range as well. We'll have to modify it, right? So we can modify this algorithm a little bit to yeah, one is asking for code. Yeah, so let me write the code so that you can understand it clearly. Again, the code is written there on Geeks4Geeks. So let me. So again, I'll be sharing all these links with you, and the logic is also explained here. So if you're not able to understand through this video, then you can try this thing from here. And here we have the code. So let me explain this code for you. Again, you can find this code in Java, C++, Python, C#, and PHP. So let me pick the C and C++ code. I mean, you can use anyone, right? So the idea is simple. We have a Boolean array, which is prime. So it's the array in which we are marking things. And initially, all of them are set as true. So memset is a function which will set that array with true value. So all these values are prime initially, right? All these values. For all these indexes, value is true. That means okay, all of them are prime. Then again, we are starting from 2, like 2, then 3, then 4, and so on. And we will move to again the squarity of n, because in that range, so I can explain this thing, but it would be better if you can, find the logic behind this, like why I am iterating till squarity of n only, like why we are not iterating till nth. So this is the one thing that you can think about by yourself, that why we are doing this thing, like why we are iterating till only squarity of n. That's the one thing that you have to think. Uh, Again, the idea was if that number is prime, like for 2 it will be true, right? Because 2 is a prime number. So for 2 it's true. And what we are doing is we are starting from multiple of 2, like you're starting from, you can go from 2p, like from 4, then it will be 6, then 8. So basically we are finding the multiples of p, right? That prime number p. So we are simply adding p in that number. It's 2p, 3p, 4p, and so on. And we are marking all of them as false. So this is how we are marking other numbers as false, right? And then again, what we are doing is, if that number is, and again to print them, we are using that array, like this array, to know about, okay, which number is true and which number is prime or not. So if for that number, if it is a prime, like if this is true, then only we are printing it. So we are printing that number. So this is how we are printing all the numbers in the range of from 2 to n with the help of this Sieve algorithm. Because in this array, if a value is true, that means, okay, that number is a prime number. So now we can find that prime number in O of 1. If we have this array somewhere stored, then we can check whether a number is prime or not in constant time, because we are simply doing something in the array, right? Again, this step will take O of n because we are iterating in the array. Okay, so in Java, you can simply iterate in the array and you can set that value, right? Okay, yes, it's not O of 1, but it's better than O of n cross square t of n. It's better than that. It's not O of 1, it's better, but it's better than that. And also it's more than, in fact, like this step will take O of square t of n. This step will also take some time. So now it's your task to find the time complexity of this problem. So it's your homework to find. Again, I don't want to make the sessions only one way. So you will have to, like, the idea is I'll be discussing some of the questions. I'll be giving you some assignments in those questions itself, like to find the, I mean, or to calculate the time complexity. It's your task. I'll talk about like why the time complexity of this problem is something, right? So I'll talk about that in later in the next lecture. I mean, I just want to give you some time so that you can understand, so that you can try these things by yourself for the first time, and then I can talk about these things. Again, for, let's say, for third week, or for from fourth week, uh, like we'll be solving question in the class itself. Like I'll not be giving you some homework like this. Of course, you will have assignments on the course page. I'll talk about everything in the class itself, but for this week at least, I want you to try a few things by yourself. That's why I'm not completing all these things here only, right? So now it's your task to find the time complexity, this complexity by yourself. Again, it's not that easy. It's a little complex. That's why I'm giving this thing as an assignment, right? That, so that you can take your time and you can analyze the time and space complexity by yourself. So any doubt in this approach, apart from time and space complexity? Well, yes. Let me show you like how you can access the portal, right? So I hope all of you have. I hope all of you have this access to this course page, right? The DSA workshop, and I hope all of you can say this thing. Like this is a week 1 and week 2 and so on. So here, let's say if you are accessing the tracks of, let's say, array, then you have theories like what is array, how you can write code for arrays in that thing, what is error rotation, right? Similarly, for basic mathematics, we have uh, yeah, like here we have one thing called yeah, like what is prime number, how to check for prime numbers, then what is C algorithm, right? So in the theory section, you will have everything. Apart from the theory, you will have problems, practice problems, right? So you can try all these problems by yourself, like what is uh, yeah. So you will have this kind of problems. So I hope all of you have access of this course page. Apart from that, I'll be sharing the class notes that I'll have. Like I'll be sharing my PPTs and all these codes with you. We'll do that. Yeah. So okay. So yeah, week 3 will be shown after. I mean, once we are done with the week 2, right? That's why you can't see week 3 right now. So week 3 will be visible at the end of week 2. Is that clear? Yeah, because week 3 will be visible after week 2, right? So that's why it's not there. I'll quickly discuss one more problem. And again, this was the first lecture, so I was not discussing with a good speed. But from next lecture, you can expect some you can expect little uh, more speed, right? Yeah, that okay. So yeah, so this thing like why p cross p is less than n is something that you will have to find by yourself first. I'll talk about that thing later in the next lecture. So it's a homework for you to figure out like why this is p cross p less than n. Second thing is what is the time and space for this problem. Third thing is like how we can optimize this problem, how we can optimize this function to O of 1. So yeah, so these are the few things that you have to think about before the next session, which is tomorrow. Okay, let me quickly discuss one more problem. Like uh, problem is printing all strings of the string. Let's say if you have something like is equal to ABC, right? Then its substring will be A, then let's say B, then sorry A, then AB, then ABC, then B, then we have BC, then we have C itself, right? So we'll have total 6 substrings. In other words, if we have something like if you have n, the length of a string is n, uh, then the total number of substrings will be this is b uh, n cross n plus 1 by 2. That's why for 3, the total number of substrings is right, it's 3 cross 4 by 2, which is 6. That's why we have 6 substrings. The question is we have to print all the substrings of a string. Can you tell the most important part? So Simon is asking, can you tell the most important part rather than rating them being just homeworks? Everything is important, right? So you can't skip anything. So everything is important here. Okay, so yeah, so how we can find all the substrings of a given string. Yeah, substring is continuous, right? Yes. Yes, you can use any language. You can use Python, JavaScript, C Sharp, C, C++, any language is fine. Okay, sorry, AC is not this. Yeah, AC is not a substring, right? AC is not a substring. Yeah. Or let's say substring of let's say yes, S2 is equal to let's say uh, PQR. Then substring will be again P, then PQ, then PQR, then like that. Well, it's quite simple. So the purpose of this question is just to make you guys comfortable with strings, right? Because we'll be using a lot of strings and arrays. So that was the reason of discussing this problem, right? So let's say we have a function called int all substrings. We have the string is. What we can do is, and I have actually the code, so let me save some. You simply find it code this code at Geeks. So about uh, see carefully. What I'm doing is substring will start from each character. Like from P we have three substrings. One is P, one is PQ, and one is PQR. For and from each index we'll have some substrings. Like from P we have three substrings: P, PQ, and PQR. So that's why we have this loop which will go to each index of that string. Similarly, for Q we have two strings, Q and QR. We have two substrings, right? And for R we have a single substring R, right? Uh, Again, the length of substring can vary. Like for P, the one length is 1, then 2, then 3. Okay? So the length for a given index I could be from 1 to n minus I. It's like again for P, I is 0, right? So I'm not talking about the character P. For this character, we can have substrings of 3 length. Length 1, which is this. So this is of length 1. This is of length 2. Of length 3, right? So what will be the range of that length? So the range of that length will be from 1 to n minus I. So the range will be 1 to n minus n is 3. So it's 3 minus 0, which is 3. Right. Similarly, for the last index, right? If you talk about this index, so for if I talk about, okay, let's say if I is again here I is 2, right? Index is 2, and we are talking about the character R. For this character, the length of substrings will be from 1 to n minus I, and n is 3 and I is 2, so it will be 1. That's why we have a single substring starting from R of length 1, right? Okay. So that's why we have something like this. And okay, now we know that okay, this is the starting index, and This is the length of that character. So what we can do is we can simply uh, can have a string called, let's say, something, this string, right? And we can, let's say it's an empty string. So let me create a substring. Let's say this is a substring, right? This is the substring, substring. So basically, I'll add those characters. Like to create PQR, I'll have to add P, then Q, then R, right? So for that thing, what I can do is I can iterate like for is equal to. So I'll start from ith character, and I'll go till I plus n, right? A plus plus. Starting from ith character, and then I'm going till the I plus length. Like in this case, I'm starting from zeroth index, and I'm going from 0 to, sorry, I'll have to go less than I plus length. I mean, because for length 3, it will be less than 3, right? So I'll have to iterate from I to I plus length, right? And I can simply, like in C++, you can simply use plus. In C also, you can uh, you can append that character. Like you can create a string, or you can create a pointer, and then you can simply add that character to that string, right? So I'm simply, I'll add that character, I mean that jth character to my substring, right? Once I'm done, I'll print that. Again, this code will work in any language. Like I mean, this code, you will have similar code in C++, in Java, in Python, in any language. So that's the idea. Yes, it has very high complexity. It's I plus n. N means the length of that substring. Yes, the code can be optimized a little bit. Garima, yes, we can solve this problem using bit manipulation as well. Okay, see, let me talk about the next session, right? So the idea is that in the next session, the first thing, like I'll talk about the remaining things. Like I'll talk about these homeworks that I have given you. That can be covered in, let's say, 10 to 15 minutes. I won't take much time. Right, and then we'll solve some questions on arrays, right? We also use some mathematics, and then we can start searching and sorting as well, right? So that's the idea of next lecture. So in the meantime, you can ask your doubts if you have any. Okay, so someone is asking what is the criteria for certificate. So it's not yet decided, but you will have to solve some questions on that course page to get the certificate. Okay, yes, I'll be teaching faster. So this was the first lecture, and some of you are not able to understand. That's why I was teaching slowly. But from the next lecture, we'll increase the pace, right? So yeah, and also you can fill the feedback form so that we can improve things for from the next lecture or from the next week. So you can, I mean, fill that feedback form, and also you can, I mean, let me know if something like what are the things that went well, what are the things that can be improved. So you can write all these things in the comment as well. Yeah, so we'll talk about all these things. Like we'll teach graph and deep and everything. So don't worry. This was just the first lecture, so you can't expect a lot of things in the first lecture. Yes, I'm done for today. And also again from next week, like you can't, so again from the next week you will not have things on YouTube. Like you'll have to register for the course. So if you have not registered for the course, you will not be able to watch those videos or watch that live session. So make sure that okay, you are in the course so that you can access the tracks and everything. The length of each lecture will be 2 hours. So the timing will be from 6 to 8 p.m. EST on Wednesday, and that's the timing for. Yeah, I'll share this document with you. So I'll share this thing with you. So yeah, so we are planning to have like again, I mean, we have your email ID. So either we can share these things on your email, or we can do something, or we can upload it somewhere on the course page itself, so that you can access it easily. All these things will be shared with you. Okay, someone is asking, can you explain about meme set, right? So meme set is a function. So this simply sets something in the array, right? So instead of this thing, what you can write is you can simply write it in the comment. So what you can do is you can simply put in there, like you can iterate in the array equal to 0 to I plus plus. Let's say prime of I is false, right? Either you can write this for loop to sorry, it should be true. So either you can write this for loop to make all the values in this array as true, or you can simply use meme set like this to set all these values in the array as true. So this means simply iterating in the array like this and initializing all the values with a single value like true. That is the meaning of meme set. Okay, so I'll okay. Okay, so I'm done for this for today's session, and I hope you will try all the assignments that I have given, and then we can discuss some new things tomorrow. Okay, so let me take a few more questions from the chat. Yes, we can use vector, right? Okay. Okay, to I mean to ask that, what we can do is we can simply ask in the chat section, right? So that's the only way for now. So I'll be reading the comments. You can ask in the comment itself. You ask your doubts in the comment itself, right? Also, you can ask your doubts in that feedback form. So in that Q&A form, actually, we have a Q&A form where you can ask your doubts. So you can try that thing as well. Also, if you have any issue, then what you can do is you can simply mail us on that given email ID. Sorry. So on the course page, you can find. Let me show you. So if you're facing any issue, right, like any technical issue, then you can simply uh, mail us on on this given email ID. It's geeksclasses@geeksforgeeks.org. So this is the email ID where you can shoot us for any query or any issue that you are facing, right? So yeah, contest will be there. Okay, so thank you so much for watching me. Thank you guys. Bye.